sometimes we cannot obtain all of something that we want or that we need. So there are constraints. And what we have to do is we have to learn to work within those constraints and do what we can do to maximize a constrained resource. I don't know if you've ever done the Labor Day bridge walk on the Mackinac Bridge. I haven't. I know what it is. I've driven across the Mackinac Bridge a lot of times. And so this is a picture of the Labor Day bridge walk at Mackinac Bridge. Normally 4 lanes of traffic, 2 going northbound, 2 going southbound. But at least in its former iteration, the way they used to do the bridge walk, the Mackinac Bridge Authority would close down one half of the bridge. So now traffic suddenly is forced to be in 2 lanes instead of 4 lanes. There's only one bridge. That's a constraint. There's a constrained resource, which is the bridge. And if we close down 2 lanes of traffic, we have to deal with that constraint. Now, in terms of manufacturing, let's think about this here. Now, initially, we've got a company that sells tables and benches. And you guys you're very well versed at this point in contribution margin. So you can see that if we sell 1 table, our contribution margin will be $24. And if we sell 1 bench, our contribution margin is going to be $15. On the surface, it looks like tables are a better bet than benches. But here's the thing. They both require processing time on this particular machine. And what we're seeing here is that the table requires 1 minute of processing time, whereas the bench requires half a minute of processing time. So what we want to do is we want to look at what is the contribution margin per unit of constrained resource. And for a table, it's going to be $24 of contribution margin per table. And in 1 minute, how many tables can we make? We can make 1 table. So if we divide that by 1 minute, then what we're seeing here is the contribution margin per minute of machine time is $24 for a table. Switch over to the benches. Well, a bench, the contribution margin is only $15 per bench, okay? But we can make 2 benches in 1 minute. So what we're seeing here, with 1 minute of machine time, we can actually generate $30 if we make 2 benches versus the $24 if we only make a table. And so even though the contribution margin per table is greater than the contribution margin for 1 bench, the fact that we can make 2 benches in the time it takes to make 1 table suddenly makes the bench more attractive than the table. Now, that bench is really only more attractive if there's a constraint with the machine time. And our constraint is going to be this, okay? 2,400 minutes per week. We can only get this amount of machine time out of that particular machine, that machine A1, so cleverly named in this example. So if we only have 2,400 minutes a week, and we know we're not going to be able to satisfy all of this demand for the 2,200 benches and the 2,000 tables, then what we should do is we should initially focus our production on the item that has the highest contribution margin per unit of constrained resource, which we know is the benches, $30 a minute versus $24 per minute. So let's make as many benches as we think we need to make. In this case, we're going to let customer demand be the upper limit. So if customers demand 2,200 benches, we're going to need 1,100 minutes to get that done. 2,200 benches times, what is it? It's a half minute per bench. So we need 1,100 minutes of machine time to make the benches that our customers have demanded. So let's do that. That's the most profitable use of this constrained resource that is a machine. And if we do that, what we have left over, see, because the leftovers are going to go to the production of tables. So if we have a maximum of 2,400 minutes available for any particular week, And if we use 1,100 of those minutes to make the benches, that means we have 1,300 minutes available for tables. Well, the math is going to be pretty easy here, because if we have 1,300 minutes available, we have 1,300 minutes right here, and each table takes 1 minute per table. Then we can make 1,300 tables. This is what we would call our profit maximization scenario. We're going to make 2,200 benches. That satisfies the demand right here. We're going to make 1,300 tables. Does not satisfy our demand for tables. However, it's reality. We only have so much machine time available. So we focus first on the highest contribution margin per minute of machine time. That was the benches. Make as many of those as we need to make. Hopefully that leaves some time left over. It might not. That might use up all of our machine time, but hopefully it leaves some time left over, like it did here. So we can make 1,300 tables with the remainder. Yeah, there's going to be 700 tables for which demand is unfulfilled. Now the question we would have is this. What if there was some way that we could get our hands on some additional machine time? Maybe purchasing another machine, renting a machine, outsourcing some capacity to a different manufacturer. How much would we be willing to pay for that? And the answer is this. The most we would be willing to pay is $24 per minute of machine time. Because remember, the contribution margin per minute for tables was $24 per minute, right? We could earn $24 per table, and each table requires a minute of machine time. So if we did have another minute of machine time, what would we do with it? Well, we would make some more tables and try to get up to the 2,000 that customers want to purchase. So the value of an additional minute of machine time is 24 bucks. Now, if we did spend $24, we would essentially be trading dollars. In other words, spending $24 to earn $24 of contribution margin. So in a lot of cases, we may treat this as the upper limit. We would not want to pay more than $24. But of course, we also might choose to pay more than $24. Not for quantitative reasons, but for qualitative non-financial reasons, perhaps just to save face with our customers or to preserve goodwill. So the quantitative analysis suggested that we should make benches first because they generate a higher contribution margin for every minute of machine time. And then we should let the tables have the leftover machine time. Simply because machine time is precious. It's a constrained resource. We can't get enough machine time to make everything that we want to. So we focus on the more lucrative option first, the benches, and then we move on to the tables. Now, that might be fine on paper, and that might be what the quantitative analysis suggests. Don't forget about qualitative considerations. Take this for example. We make a whole bunch of benches. What if people don't want benches unless they can have a table too? What if it's often purchased? What if these are often purchased in conjunction with one another? One table with maybe 2 or 4 or 6 benches around. So people don't want to buy benches unless they can also get one of our tables. So we may have to make a compromise for non-financial considerations as well. It could be because of our product mix that we're going to have to make fewer than 2,200 benches and also fewer than 2,000 tables so that we keep our customers the happiest we can possibly keep them. Of course, we have to do that analysis, and that's probably the sales and marketing folks or somebody in charge of customer relations. But it's going to be a cross-functional decision that includes both quantitative and qualitative analysis. I don't know about you, but when I see that we're leaving some customer demand unmet, that gives me a pretty uneasy feeling in my mind. I've owned businesses over the years, and I just know that I don't want to turn a customer away. It's hard enough to attract customers to our business and to convince them to purchase our products. So if we already have customer demand pent up, boy, I don't want to turn them away. So what can we do to maximize the constrained resource? What can we do to manage this constraint? So it's going beyond the calculations. What can we do to make it better? One of the options is simply working overtime. Additional labor hours certainly could fix the problem, at least temporarily. You might want to look at a more permanent solution that might be less expensive than labor at time and a half, but sometimes just working the extra hours will get the job done. Outsourcing. Maybe we outsource some of the manufacturing to another supplier. And we may not want to do that in the long run either. It might be more expensive than we prefer. There might be other reasons like quality control that we would prefer to do it in-house. But temporarily, that certainly is something we can do to try to relieve pressure at that bottleneck. Acquiring assets. We could buy more machines, or we could potentially maybe even rent some additional capacity at a bottleneck. But capital acquisition is an option. Probably one of our more long-term solutions as well, really. How about reallocating resources? What if we have the constraint at the bottleneck, but then we have other processes where we have a bunch of capacity and idle resources? So what we could do is we could shift workers or other resources from non-bottlenecks over to bottlenecks, and at least in the short run, that could fix our problems. Of course, improving processes overall sounds like a wonderful long-term solution, because if we're going to make things better, this could improve the throughput, could improve the efficiency at the bottleneck, and of course, that could only help things overall. And then finally, how about reducing defects? So if there's still going to be a bottleneck, if all of these other options right here, working some overtime, outsourcing, any of these things, if we do them and we still have the bottleneck, then let's at least make sure that we're using that bottleneck process as efficiently as possible. So increasing quality, reducing defects, what that means is at least the output, the throughput that's coming through that bottleneck is good stuff that we can use, we can deliver to our customers. If we are pushing products through that bottleneck that have defects, and so we have to scrap them, waste them, or maybe just have some rework to make them acceptable for our customers, then we're not using the bottleneck as well as we could. Reducing defects will also have the ancillary benefit of bottom line profit increases, reducing costs, probably increasing customer satisfaction. I kind of like that whole concept of reducing defects. So these are things that we can do if a constraint is going to exist to at least manage that constraint. We may not be able to completely eliminate it, but we certainly could improve it.